Hello, we have a real short video on exceptions to the filling order. So I just want you to be aware that as with all the rules we tend to learn in chemistry, there are some exceptions to it. So we just gave you, that filling order of what comes next. So first 1s, then 2s, then 2p, then 3s, then 3p. And it turns out we will notice some exceptions to that rule. These are not things you have to memorize, but they're things you might encounter. So you need to be aware of them. And okay, so here's an example. Here's our filling order that we talked about over here, right? And let's say we looked at copper, which copper is right here on the table. Our predicted electron configuration, if we were following this pattern, would be, 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d9. That's what we would expect to see because it's the ninth element in that 3D block. What we actually observe is that this is the electron configuration. So instead of 4s2 3d9, it's 4s1 3d10. So that's what I mean when I say sometimes there are exceptions to this pattern. Why do these exceptions occur? It has to do with quantum mechanics and the energies of these orbitals. So the real answer is somewhat complicated, but just be aware that some subshells have very similar energies. This tends to happen in the D block. So for example, like the 4s and the 3D subshells have similar energies. You also might notice this happening when you transition from the S to the D and the F down here. They have kind of similar energies. So there's a pattern to when we tend to see these exceptions. They tend to typically occur with elements you would predict to end in D4 or D9. So notice back here, we predicted that copper would end in D9. And notice how it's just one away from being filled. So it turns out, because of quantum mechanical reasons, that having this subshell filled is actually a lower energy state than this is right here. So it tends to happen when the electrons are close to either being half full or completely full, which happens in a D4 or a D9. So here's an example right here, chromium. If you look here, this is the fourth element in. So we might expect it to be 4s2, 3d4. In reality, it's 4s1, 3d5. And I want to point out this visual I got from ptable.com. It's a cool resource, that interactive periodic table. Keep in mind you will not be able to use this resource on the AP exam. So this is something you could use to maybe check your work as you're trying to write out electron configurations. But you don't want to get in the habit of just Googling answers to these, because you do need to be able to do these electron configurations on your own. And here's some other exceptions down here where they occur in the F block. You might notice some weird kind of numbering happen here, 56, 55, 56. Some tables show 57 up here, some show it down here. It's because some weird stuff happens here. So barium ends in 6s2. Lanthanum is 6s2 5d1. So that extra electron goes in the D, which is why our periodic table, I believe, shows it up here in the D block. But then our next one, cerium, is 6s2 5d1 4f1. So the next electron goes in the 4f. And then when you get to the third one and beyond, then the electrons just go straight into the 4f. So here's the exception to the rule would be, like in general, we'd assume the rule is that you fill 4f before the 5d, but there's sometimes some exceptions when there's only one or two electrons. You might have one go in the D first before the F. So that's what we mean. So it's just something to be aware of. Again, you don't need to memorize these. And yeah, that's it. Thanks for watching.